How's it going, ladies and gentlemen? Mr. Donnie here with some 13.4 problems, ways of expressing concentration. All right, so a lot of math in this part, and it's all multiple step math too. So there's not just find one formula, plug it in, and it's done. So it takes a lot of thinking, critical thinking, and planning out what you're going to do. So let's take a look at the first problem. It says calculate the molality of 25.4% by mass aqueous solution as phosphoric acid. All right, well, let's think about this. What do they tell us? First thing that they tell us is the percentage, right? Well, that's by mass. So we can go from percent and we can get the masses of the solute and the mass of the solvent. So we can get those masses. All right, once we have those masses, well, what are they asking for? They're asking for molality. So you got to know what molality is. It's moles of solute over kilogram of solvent. All right, so using the percent, we can get the masses of these things, the solute and the solvent. Now, mass of the solvent is what we're going to use, but now we got to do something with that mass of the solute. So how do we go from mass to what we need in moles? Well, GFM, right? And then once you got that, then you can plug it into your molality equation and solve for it. So let's check it out. All right, well, how do we use this percentage? Well, what you got to do is you got to assume a certain amount of mass. So let's assume we have 100 grams. So let's say we got 100 grams total. How much of that would be the phosphoric acid? Well, percentage. If it's out of 100, then we have 25.4 grams of H3PO4, right? And then how much of our solvent? What about water? Well, if we had 100 grams total and 25.4 grams of it was this stuff, well, the rest of it has to be water. So we do some simple math and we get 74.6 grams of solvent, of H2O. All right, so now the second step, well, if we're doing molality and we want moles of solute, well, we got to convert the grams of solute into moles. So we do that by dividing by its GFM. So divide by 98.0 should be the GFM for H3PO4, and we get 0.259 moles of H3PO4. All right, so now the last step is just plugging in those numbers into the molality formula. So we got 0.259 moles divided by 0.0746 kilograms. I did the conversion there from grams to kilograms. And you get 3.47 molal, which would be choice B. 14 says calculate the mole fraction of phosphoric acid given this percentage composition. Well, first thing to remember is, well, what is the mole fraction? It's the moles of your part over the moles total. All right, so we're going to have to get moles, and they give us percentage by mass. So first thing we can do is percentage. We can get masses. Second step is we're going to have to convert the masses to moles. And then once we have the moles, then we can do the mole fraction. All right, so let's do that first step. Well, whenever you're working with percentages, it's usually pretty helpful to assume a certain mass, and I like 100 because then it's just 25.4. So we got 25.4 grams of H3PO4, and the rest of it would be water, wouldn't it? So it would be 74.6 grams of H2O. Second step, convert the mass to moles. So we do that by dividing by the GFM, which would be, I forget, 98. 98, right? And you should get the same number as the last problem. Point, can't draw, 0.25 something or other. 0.259 moles. And then for water, you divide it by its formula mass, which is 18.0, and you should get 4.14 moles of H2O. So now the last step would be, all right, well, moles over X, it wants a mole fraction of phosphoric acid, so we put the moles of that stuff up top over the moles total, which would be the 0.259 plus 4.14. And that would give you 0.0589, which would be choice A. 15. Calculate the molarity of 10% by mass aqueous solution of hydrochloric acid. Well, you gotta, well, what is hydrochloric acid? It's HCl. All right, so again, if they give us, well, what are they asking for? Molarity. So they want moles over liters of solution. So moles of solute over liters of solution. All right, well, let's think about this. I got percentage by mass, so I could do, so percentage, I can get grams from that, and then I could do, well, if I got grams, I can get moles, but how do I get liters? In order to get liters, you would need the density, right? Third step would be you'd use the density to get the amount of liters, but you don't have the density, so we can't do that step. So 15 would be choice E. The density of the solution is needed to solve the problem. Can't do it. 16. Calculate the molality of a 17.5% by mass aqueous solution of nitric acid. All right, so what do they want? Their molality. So they want moles of solute over kilograms of solvent. All right, so let's think about this. Well, if I start with percentage, I can get grams. All right, then what can I do after that? Well, if I got grams of solute, I can convert that to moles, which would be this first top thing. Cool. All right, well, I still need kilograms of solvent, which I would have with the first step. I can get grams of solute. I can also get grams of solvent. So then I can just plug it into the molal equation. So let's look, first step. If I got percentage, assume a mass. Let's assume 100 grams total. So then we'd have 17.5 grams of nitric acid, right? Which is HNO3, nitric acid. Second step, well, I want moles of solute, so I got to convert that to moles by dividing by its GFM, which let me look it up real quick. 63.0. And I would get 0.278 moles. All right. Well, I still need kilograms of solvent. So how would I do that? Well, if I had 100 grams total and 17.5 of it was HNO3, I just do the difference, 82.5 grams of solvent. So now I can just plug it in. Now I got 0.278 moles divided by 0.0825 kilograms. Remember, I got to convert grams to kilograms. And I get the answer of 3.37 molal, which would be choice A. All right, 17. It says a solution was prepared by dissolving this much NH3 in 250 grams of water. The density of the resulting solution is this. The molarity of NH3 and the solution is blank. All right, well, let's what are they asking first? Let's start there. All right, they want the molarity. So I know that's moles per liter of solution. So moles of solute over liters of solution. Well, let's see what they give me. They give me 15 grams of NH3 and 250 grams of water, and they give me the density. All right, well, let's first figure out our plan of action. First, If they give us grams, we're going to need to convert that to moles. Right, so that'll give me moles of the solute. All right, well, second step, what I'm going to have to do, well, I need liters, so how can I get that? They give me density, so I'm going to have to use the density to convert to liters. And then once I have that, then I can just plug it in and solve for molarity. So let me work those steps out. Grams to moles. Well, if I have 15.0 grams of NH3, I divide it by the GFM, which is 17.0, and I get some number, right? I'm not even going to do that. I'm going to save plugging in numbers for the last step. 2, how do I go from density to liters? Well, you got to remember density equals mass over volume. All right, well, they give us the density is 0.974 grams per milliliter. The mass of the whole thing is going to have to be 265 grams because it's 15 and 250 all over blank. All right, so the volume should equal 0.272 liters. Notice I've converted to liters. So now, last step will be, we'll just plug and chug. All right, the moles would be 15.0 divided by 17.0. That's moles. All divided by liters, 0.272 liters. And that will give you 3.24 molar, which would be choice D. All right, 18. The solution is prepared by dissolving 23.7 grams of calcium chloride in this much water. The density of the solution is this. The concentration of blank is, concentration of Cl minus in the solution is blank molar. All right, so if they want molar, remember it's moles per liter, so moles of solute over liters of solution. That gives us the density. All right, well, let's figure this out. First step is we're going to have to convert grams of CaCl2 to moles because we need it in moles, not grams. All right, once we got that, we got to figure out the liters of solution part. Well, they use the density, so we use the density to give us liters because we're going to have the mass and we know the density so we can find the volume. Now, next step, you got to be careful here. You calculate the molarity because you would have moles and liters, but this is of the solute, which is calcium chloride, CaCl2, but the question wants you the concentration of Cl minus. So what we got to do is we got to take the molarity of CaCl2 and times it by 2 because we get 2 Cl minuses. If we were to take a look, CaCl2 is going to break up into Ca plus 2 and 2 Cl minuses. So if we know the concentration of this, well, then the concentration of the Cl minus is going to be twice that. All right, so let's do the work. All right, so we do 23.7 grams divided by the GFM of calcium chloride, which is 111.0 grams per mole. So that's going to be our number of moles. Again, I like saving all my math steps for the last. 2, density, 1.05. Well, let's just rearrange the density equation, right? Mass over volume, and we're solving for volume, so volume equals mass over density. So you get a total mass of, where is it? 398.7. Yep. Divided by the density of 1.05. So that is our going to be milliliters. So let's divide that by 1,000. How are you doing? Divide by 1,000 to give us liters, right? So now we got liters. And last step, plug them all together. Moles 23.7 divided by 111.0 divided by 398.7 divided by 1.05 divided by 1,000. And then we got to do that times by 2. And believe it or not, you should get 1.12 molar. All right. 19. The concentration of HCl in a solution that is prepared by dissolving 5.5 grams of HCl in 200 grams of this stuff is blank molal. All right, so let's start. Well, what is molal? It's moles of solute over kilograms of solvent. All right. So first step is going to have to be convert grams to moles for the solute. Right, and the second step is just plug it in, right? Figure out the molal. Kind of an easier, shorter problem, I should say. So first step, we got 5.5 grams divided by HCl's GFM, which is 36.5, and that'll give us moles. Second step, molal equation. So we have the 5.5 grams divided by 36.5. That'll give us our moles divided by kilogram of solvent. So we have 200 grams of it, so it'll be 0.200. Actually, just be 0.2 if you're following the rules of sig figs. Plug and chug. So choice D. All right, there are definitely more than one way to solve these problems. I just showed you one. Right? Hopefully you found it helpful. I think it's the most common way people would solve is probably stepwise and whatnot. Bring questions to class. See you there.